Hey everyone, welcome back to the channel. Today I'm reviewing a must-have for anyone working in electronics. This book is Practical Electronic Design for Experimenters, and it's by Louis Frenzel. And this book is just going to be packed with a lot of hands-on projects that'll help you apply the design concept in the real-world scenarios, especially for electrical engineers looking to kind of sharpen and honing their design skills. So let's go ahead and dive in. So as you can see, like the copyright of this book was in 2020, so it's actually pretty recent. So all the design information that you get provided in this book are going to be pretty much up to date. And as we can see for the table of contents here, it's gives a pretty good introduction on electronic design, and then design resources, simulation and prototyping. Then we can see testing and measuring, common circuit design techniques, power supply design. That's kind of actually a really good chapter here. Amplifier design, signal source design, filter design, electromechanical, digital design, programmable logic devices, designing with microcontrollers, component selection, and troubleshooting and debugging. So these are actually a really good book. And it's also, if you can just see, it's really not that thick. It gets kind of right into it, so it doesn't bog you down with a lot of math and jargon or anything like that. So that's one thing I think a lot of people will probably use and reference this book and then be able to actually jump right in. And as you can kind of see, there's a lot of design projects kind of at the end of every chapter here. So it just kind of allows you to apply it. So you can grab a breadboard and some circuits, and you can actually just jump right in and actually apply the design concepts. And the author, he kind of basically clearly explained who the target audience in the design is. As you can see, hobbyists, experimenters, DIYers, makers who want to create their own equipment, and new engineers, graduates who are well versed in math, physics, and electronic fundamentals, but have not yet learned to apply that knowledge to creating products. Technicians who are knowledgeable in electronics but have not designed, scientists like physicists, chemists, geologists, and other users of electronic equipment who often need custom non-commercial equipment but can learn to design their own. Students who can supplement their theoretical studies with practical design knowledge, and students with an introductory college design course or taking a design capstone course or accumulating design project course where the theory is applied to a specific circuit or device. So this is very widespread. So if you're a beginner learner, or if you're an expert or advanced, or if someone with a graduate degree, this basically will pretty much bring you up to speed. So it's pretty much, it's not going to be very high level. It's going to be very much direct into how you can apply design principles and then use it in the real world. And first off, let's just talk about the approach of this book. Unlike typical textbooks with test your knowledge type questions at the end of each chapter, Practical Electronic Design for Experimenters kind of gives you something even better, design projects. And these projects encourage you to make what you've learned in each chapter and immediately put them into practice, kind of helping you think like a designer and engineer rather than just memorizing theory. And we can see right here kind of like it kind of tells you, included at the end of each chapter are several design projects. These are provided to help you apply the design procedures. The project may be just a demonstration or a major design assignment. Be sure to do these as they provide the practice you need to become competent in design. Simulate, build, and test your design. Typical solutions are given in the appendix to further illustrate proper techniques as well as the kinds of decisions that you may need to make. Make sure you read all of the design projects and their solutions in the Appendix B. These solutions give you a significant amount of additional design tips, approaches, and processes. So this is just really good to be able to actually apply what you learn. So it's not very theoretical. It does have some math, but it's not going to bog you down. It's just basically going to get to what, like, the basic algebra that you'll kind of need to actually calculate things. So I think that's what's going to be actually really a key selling point for a lot of people getting this book. And kind of right off the back, it kind of helps you how to actually approach electronic design. And here is like the design approach introduced here is covered in these basic stages: definition, design, detailed design, simulation, which is optional, prototype, testing, unpacking, or packaging, and use. And then actually has the step breakdown and kind of like block diagram to kind of help you give a mental model of how you want to approach your actual project. So if you have an electronic project that you want to do in mind, it kind of helps you break it down on how to think logically about how you're going to actually work out the solution to actually build the project. And I think that's extremely helpful for someone who maybe go through an engineering or they're DIY, but they don't necessarily kind of have the means to be able to think about it in a practical way. They can just kind of help at least think about it in a more methodical and logical way to help get them started and be more efficient in their actual design project. So, now this chapter is a big reason why I purchased this book. Every electronic project needs to be powered, but this actually goes through methodically on how to actually build power supplies, both linear and switch mode power supplies. And also discusses like if you want it to be portable, using batteries, or actually solar powered, and all the different requirements that you actually need to think about to actually supply power to your electronic projects. So as you can see, it says like every electronic project needs a power supply. All electronic circuits rely on one or more DC voltage for power. As a result, any design effort should start by acknowledging the need for a power supply. You should design or specify the end product first to determine the voltage and current requirements of the supply. This just really kind of clearly lays out what you actually need to be thinking about when you're designing your electronic projects. And it talks about how to actually specify and what choices you actually need to look through. So for example, you got a block diagram for general block diagram of a battery power supply, a block diagram for an AC power supply, the main components of a solar power supply. So it helps you to visualize and see how your project should be set up, and it discusses the common types of voltage, designing a battery supply, everything that should kind of go into it. Here, as you can see, it talks about lead acid batteries and lithium ion and alkaline batteries, and basically the pros and cons of each, the type of cell and battery, its usual voltage and the amperage, and if it's rechargeable or non-rechargeable, and how to calculate the amp hour ratings. So this is all kind of useful if you're actually trying to make portable battery-powered projects. Now we have the battery supply design procedures. And like I said, here's the basic steps, step-by-step design procedures for a battery-powered device. Identify your voltage needs. What voltage do the ICs and other circuits operate from? What are the voltage requirements of any modules or subassemblies you may be using? Number two, also estimate the current needs of each voltage source. As a safety factor, increase your current drain estimates by 10 to 20%. And number three, either select primary or secondary batteries. Primary batteries are not rechargeable. When they die, you have to replace them. That is the best choice for some low-price products. Secondary batteries are rechargeable. That means you will need a charger. Will the charger be an external unit or built into the product? So these are just all the things you kind of want to think about when you're actually designing your electronic power, your projects, and you're going to need to power them. And if you're going to be powered by battery, this kind of walks you through and everything that you kind of need. Also has very good diagrams on what you're actually looking at. If you want to power like an LED and what it actually needs to, you have a load source, it's going to drain some of the battery, and that has some resistance values and everything like that to it. So it's really good as far as how to do the power supply and design aspect from sourcing it with the battery. And as you can see here, it goes through specifying a linear power supply. So there's going to be case uses on when you want to use a linear power supply, and there's going to be special case uses of whenever you want to use a switch mode power supply. And this actually goes through the pros and cons of when you would use one and prefer in preference over the other. It talks about the different type of regulators, which is very important. There are so many different type of regulators, and they all have their specific purposes. So it's very important to actually go through and understand that. And like I said, there's some math involved, but it's really, really down to earth. It actually just gives it to you and say, like, here's what you need to calculate when you're trying to look at load regulation. So that's basically all there is to it. It doesn't have to derive anything. It's just like, for safety reasons, this is what you need to consider. And you may have to kind of pause and read this, but this is basically the linear supply design procedures. And I thought it was pretty good at least making me comfortable to be able to design one myself. And then here's the switch mode power supply. So you may need to pause it and read it, but this is basically kind of an overview of why switch mode power supplies are used and why you would want to use one, and especially the efficiency, how it's calculated. And here are kind of 4 design projects at the end of the chapter that helps you put the knowledge that you just read into action. So I think these are pretty good projects, and at the end, you can actually go through the appendix and see how they would actually solve it. And here we can see at the end of the chapter the actual solution for those design projects. They kind of help you out and work through how you would actually design this on your own. And you can see they actually have the diagram for how you would wire everything up. Pretty useful. Discusses solar powered projects in here as well. So this book is great to be picked up by engineers. For one reason, it's practical. Frenzel doesn't bombard you with theory. Instead, he kind of just focuses on how to think about and apply electronic design principles to like real projects. So I would recommend this book to anyone, and I got it for about $20. And so that's all I have for this review today. Take care.